This is my 13th Java on Oracle World, and pretty much most of the time it is very cloudy. But this year it is very sunny because the cloud is inside Moscone and inside Hilton. Because all the vendors have taken the clouds and put inside the conferences. So it's sunny. So you guys probably enjoying the sun here in San Francisco. So I'll try to make it a little bit lighter because it's towards the end of the day, and it's a BOF, not a formal presentation. So how many of you guys are using cloud, like cloud-based applications? Like, have you guys? I see a few. So are you deploying this in your private cloud or really in a public cloud environment? Public? Private? Okay. Does anyone need any introduction to cloud besides it rains? Okay, so I'm not going to spend a lot of time on just introducing cloud because everybody probably knows cloud by now because there is a lot of hype going on around everyone, and I'm looking for the cloud that rains money, like all of you guys. So as you know, like 3 flavors of the cloud or avatars, you can say: the infrastructure as a service, platform as a service, and the software as a service. So most of the developers hate, if you are not developing SaaS, then you hate SaaS because most of the developers think the SaaS is going to take away your job. But all the developers pretty much love infrastructure as a service because they always think that they want a VM where they can play around and learn about new product and technology. So how did we came into this? Pretty much about 30 years back, we were in mainframe technology. I haven't seen that age. Probably some of you guys have played around with mainframe, and mainframe had a lot of concept of virtualization and all these things which are borrowed. And then we came to the mini terminal, mini computer, and the dumb terminal. And that's the time I started my journey with computers. Like then doing telnetting from your PC, and most of the time the dumb terminal didn't work, the keyboard, or like you get this green screen. If you remember the DEC 200 or BT 220 terminals. And then we came to the client server architecture where you have started building application with Oracle Forms, Visual Basic, and all this. And we had in the middle the database. And then we came to the multi-tier and SOA application, where SOA came to solve the world hunger and haven't solved it yet. But it was a grand promise with solving all the world hunger from at least the enterprise world. And then now we are in the cloud computing, where the buzzword is like everybody loves cloud computing because it is going to reduce cost for most of the organizations and give a lot of flexibility in deploying application. So why performance to the cloud-based application is critical? So you see many failure in different places, different cloud vendors, or your own application. So most of the cloud-based applications really affect your end user. That's where your money comes from. And now people are moving to private cloud, where you affect your internal users. But when you really talk about cloud, the public cloud, you're deploying your application to the end user. And if it fails or has some performance issues, then you really impact your end user. And some of your competitor is taking away that customer from you. So what are the differences like between? So I'll just there's the myth we have that most of the people think that cloud-based applications are always deployed in the cloud or in the internet. But as some of you guys have started deploying your cloud-based application in your private cloud, and something like your custom applications are always customer facing, external customer facing. But many of the customers, many of the people have started deploying their applications, which are internal bound application, which is, and they don't want to invest on a lot of hardware. And like for example, some people who have started deploying bug tracking system in the cloud instead of spending a lot of hardware in there. And it's an internal application for the developers. And then all this hype of big data, like if you go, everybody talks about big data, Hadoop and all, but not all applications are that require all this technology. And not all applications are suitable for cloud. If you remember, like about 10, 12 years back when the Java EE came in, everybody thought this is going to solve the world hunger, and EJB is going to solve all the problem. Everybody started building their applications using EJB and remoting and all this thing. Although, and most of the developers loved it because they wanted to re-architect their applications to suit whatever they're learning on. So they do not care about, like as a developer, we do not care about what the business needs are most of the time. We care about how this application is going to be good architected and the modern architecture and all. So you have to think about it's like re-architecting all these applications and deploying in the cloud. Cloud is not going to solve all the problems. So think about your application, whether it makes sense for your cloud. And then gone. Let me see. Okay, back. Okay. Now it's going to yeah. So when you have your applications in the cloud and the internet fails, you're just doing nothing. Okay. So so it's like that. So slight flick is going to create a lot of problem to your customers too. So then it's great for startups because they do not have to have any kind of initial investment. So if you look at the .com boom, most of the, like Sun was making a lot of money because they're trying to sell a lot of hardware and to the startup because SolarAce was very popular. We are the .net in your net, .com. Your dot in your .com, you might remember that. But these days, if you are starting a startup, you do not buy any hardware. You build your application in a cloud environment like Amazon EC2 or Terramark, whatever you think is appropriate. And a lot of enterprises are trying out small customer-facing applications, and many of the enterprises are trying cloud primarily for their testing environment. Like, for example, if you have applications and you do not have appropriate hardware, you just reserve some 50 VMs in EC2 and test out your applications. That's what most of the larger size of enterprises are using. And then out of this infrastructure service and the platform as service, infrastructure as service is quite popular, and the Java PaaS are still emerging. And the private cloud is getting a lot of popularity with the large enterprises where they have a lot of different hardware by different departments, and then they're trying to consolidate together and making a pool out of that and kind of providing a private cloud infrastructure to them. And what they are doing is, instead of putting in a large like HP Superdome machine, they are using a lot of small VMs and leveraging that even for third-party applications or three-tier applications. So this is the enterprise world that happened. Like, for example, if you have an application, and if application doesn't work, the support guy will say, someone will fix it. The developer says it's a problem in the DB, or the DBAs. The DBAs are in Moscone, so we can give as much hard thing for them. Okay, and then this DBA says, no, it's a problem in your application. You guys don't know how to write SQL, and you're not using the right word clause, and all this kind of thing. Problem happens. But when we go to cloud, the problem could be in the network itself. It could be problem if you're using content delivery network. It could be in the content delivery network. It could be in Amazon or wherever the infrastructure, wherever service you're using. That could be there. So whom are you going to blame if you do not have proper monitoring and diagnosing products and in place? So the challenges for most of the cloud-based applications is a highly distributed systems because you're trying to use a lot of services Like for example, if you are building a completely new application, so let's think about you're building an application in Amazon and you want to go to use everything on Amazon. So you want to go use the relational database service for storing your data. You're storing large object, you're going to use the S3 service. And if you are going to use, for example, sending in a lot of cloud vendors, they do not have even ability to send emails. So use a email service provider, like Amazon, for example, has simple email service. So you use a lot of service if you are, it's a real application. And there is a lot of tiers there, and you have no control over hardware. There could be a network problem. It could be not properly tuned application tier, and you have no visibility. And which users are getting impacted, what kind of error they are running into, where the problem is. So what kind of problems you may see? If it is a real application problem, there could be a Java memory leak issues, bad coding, infinite loop. Does it sound ring? Does it ring in your brain? Sometimes you use that. You do not do proper exception handling. SQL query could be a big problem, because most of the time whatever you see is that application slows down because you do not have right SQL or missing indexes. You're doing a full table scan or that kind of problem. Could be deadlock, could be improperly tuned application server. Or even if there is no problem in the application, there is no problem in the database. But many of the applications slows down because the database connection pool is not tuned properly in the application server level. Or there is a connectivity issue between the from the mid tier to the database tier. If you're using those in your and this is a problem both for the enterprise applications as well as for cloud applications. So, like if it is a really cloud-based application and your users are end users, so what do you care about? Is that whether your VM is slowing down or if that doesn't matter. What it cares about is whether your users are impacted or not. If you have, for example, let's say set the right elasticity policy in your application, and if one slows down or you see this application is slowing down and you fork in another VM that is doing down. But how do you see which users are impacted and what is the real problem is? Because you may be spinning more VMs, but still you may have the problem. So you have to find out which function or which transaction are failing out, because it's maybe login function. Basically, whenever somebody is trying to log into your application, that may be slowing down, and why it is slowing down, where the problem is. And or else if you are using a lot of objects, and if you're using a CDN like Akamai, and it's the Akamai where the problem might be, the content delivery network. Or it could be your line of the code. So how do you diagnose this problem, where it is? So there are some of the symptoms for applications. Like for example, it's maybe slowing down very slowly. It's like overtime or under load. It could be a memory leak. Or it even could be like, for example, initially like I was working with an insurance company couple of years back, that their application for the first 6 months it worked great, and slowly it's slowing down, and I finally figured out, and then from 5 seconds it started taking 2 minutes for some of the like insurance rating function, and it was primarily full table scans going on the table, and they were using, for example, Hibernate, and basically the developer had no idea about what SQL are being executed underneath, and there was no index on that specific table because they had not worked with the DBAs. And finally we figured out, okay, nothing is happening in the mid tier, database is tuned properly. What is the problem? So we looked at the SQL statement, and there were some of the SQL statement, they had a million rows, and they were still doing for example full table scans there. So there are several symptoms. I do not have to go through one by one, these slides are going to be available for you guys to look at it. But there are some of the symptoms for the application problems. But how do you diagnose this? There are several approaches we use. Either the log files, either you look at the monitoring metrics for your application server, or you try to read on that physically. So try to take that and read on in your test environment. See, like some user will complain, for example, my insurance rating is slow, but you try to read on that in test environment, is not going to happen because you will not have that much data in your environment. So I think this is just a little bit slow a little bit. And then there are several application performance management tools that you can use to diagnose the problem. So there are challenges in each approach. So let's talk about the challenges. So like, for example, if you're logging, if you do a lot of logging in your application, it is going to slow down your application. Because, Apache Commons or even the JDK logging take a lot of resources. So it cannot do a lot of logging. And if you have a kind of a multi-tier applications, like even the couple of tiers, or and when the problem is happening, it's very difficult to diagnose the problem because correlating the log is not that easy. So there are like tools like Splunk has a product called Storm, for example, that is helping to people do log analysis or correlation in the cloud environment. Similarly, like for example, if you are using a PaaS platform, for example, and then you are trying to correlate your log, it's not that easy because the logs are owned by them. So there are like product like Papertrail, they help you analyze the log management in a production environment. But this is primarily for historical analysis. It's not, you cannot do this in a real-time environment. It's not that easy. And as I said, it is very difficult to reproduce the exact scenario in a test environment, because when you have this, you probably have lost the actual context. So when you use the application performance management tool, there are two approaches: the server-centric approach or the user transaction-based approach for resolving or finding the problem. The server-centric approach has been there for a long time, where basically you monitor your application server, the different resources usage like JDBC connection pool, JMS connection pool, thread pool, and all this kind of thing, and you get proactively notification of this. But the problem in this approach is most of these tools, whatever built, for example, think about Oracle Enterprise Manager or CA Wiley, all these products, whenever they're built, they were built some 10 years or 15 years back. So virtualization didn't exist then. So these tools do not work that well in a virtualized environment. And if you have, because those tools were primarily, for example, if you look at the instrumentation those tools also use, it's pretty dated, like 10 years back too. So there is a lot of overhead on your applications if you're trying to do the real code analysis. But there are the tools which have been prevalent, and you may be using that in your environment at this moment. But when you move to virtualization, you have to do a lot of work, and if you are trying to do in a cloud environment, it may not work. But the tools, you can use the server-centric tool, for example, made available by the cloud vendors. If you are using a PaaS, like some of the PaaS vendors, they do provide this kind of monitoring metrics. Like for example, CloudBees. This is a example from CloudBees, where they provide the resource metrics, resources, how many number of requests, what is the memory and sessions. But this is what are the limited metrics they provide, and it's not that easy to diagnose just looking at these metrics. So this is another, for example, example of server-centric monitoring from an endpoint correlation. So then they exist basically tools for end user transaction driven diagnostics. So where you can diagnose from an end user perspective, because that's what you care about. Because when you are deploying your applications in the cloud, you want to be proactive before the users complain you that I'm not getting the performance or my transactions is failing. You probably want to know which users are impacted, what kind of problem they are having, and how do you diagnose your problem. So there are tools in the modern tools which can help you diagnose from an end user experience point of view, and then help you drill down from end user. For example, a user has a failed transaction, and then whenever that failed, he probably got a 404 from his perspective, but it generated an exceptions in the backend. Let's say it's called out of memory exceptions, or maybe a JDBC exception in the backend. So how do you tie these two together? So there are tools which help you do this, and that's what I'm going to discuss next. So there are end user experience management tools which proactively monitor your end user performance. It could be based on other passive network tapping in your cloud, or could be like some of the tools use JavaScript injection into the application and tell basically gather in more information about the applications. And then they have backend tools that the agent runs inside the application server, and the agent are built for the modern age applications, and then they use like kind of something called phone home capability. So what phone home is, like, instead of you telling instead of going to Oracle Enterprise Manager, for example, or Wiley, and telling, okay, this is where my WebLogic server is, and the host name, port number, and the user ID and password, and you give them, and then you discover the different instances, for example, in WebLogic or WebSphere or whatever. So these tools, the way it works is, you set the agent as a parameter in the application server, and you start your and you tell that tool that, okay, this is where my monitoring product is, like where the host name, port number, just do that. And as soon as you start the application server, the agent will wake up and contact the controller or the application server, the monitoring product, and tell, okay, I am awake, and this is I am. And the product will automatically discover the application server. It will automatically discover the different transactions flowing through the applications and start monitoring the transactions. And these tools can be deployed either in the cloud or on premise. And many of the PaaS vendors also support these tools. So like I wanted to just so like this is like, for example, this is tools example from our product here. So where you can tell, okay, where the users are coming from. Like this is, most of the users are from North America in here, and if you look at here, you see the red dots where basically where the user is having problem, where the users are having problem, and then you can drill down to specific users and then tell which user is impacted, where the problem is, and then drill down to the code level. And these are the tools which continuously monitor your real user. So these are real user transactions, not synthetic user like a robotic or invoke transactions. These tools monitor real users and proactively collect deep diagnostic data. Like, for example, the way it works is they do bytecode instrumentation, but yet it do not require, the modern tools, they do not require you to instrument by yourself. They automatically detect the different classes. Those has implemented J2E interfaces and only instrument those. And instead of, it doesn't require any kind of developer intervention for detecting the framework or detecting the classes, and automatically start monitoring the transactions and collect data about that. And then whenever there is a problem, you get they capture the diagnostics instances and they correlate the end user from the end user to the backend. and then tell you, okay, where the problem is. So, like for example, I'll quickly do some demo towards the end. But the benefits of these tools are there is like you understand the impact of users, and you do not have any kind of node or configuration changes in your application. These tools work out of the box, and some of the examples are like, for example, BMC, my product. I have to put a marketing plug because I'm here. BMC application diagnostics, New Relic, App Dynamics are the new tools, and then these tools, they have pretty much support for either Java or .NET. If you're using .NET, for example, New Relic has support, for example, even Ruby on Rails and other technology, and they work on the cloud environment. And then these tools, for example, help you monitor from an end user to the backend. But these tools have also limitations. Like they will automatically detect the transactions, but there is some performance penalty, like 1 to 2% of performance penalty on the application. And if you want more data, then you have to do more instrumentation. Out of the box, whatever you have, they have. That should suffice your requirement. But if you want more data, because like for example, I've been working with some of the developers, some of the organizations, they'll say, okay, we want to see the parameters. We want to see two more level of classes and how much the time is. The more and more instrumentation you add, your more slow your application is going to become. So you have to be careful when using this kind of tools too. So let me do a quick demo of how these tools work. So this is a demo of my product, but pretty much most of the product work in similar way, maybe change in here and there. Hopefully I still have my sessions here. So like for example, here I want to show you this. This is our application performance management console. Where are you seeing? Nope. Magic. Okay. So this is our application performance management console, where we have dashboard, for example, we give you the view from end user perspective, where the problems are. You can look at more details for specific state, or like you can customize this. This primarily works great whenever you have global users, but you can customize this to, for example, like state or whatever you want to do. But when we want to monitor a specific transactions, for example, here I have transactions for my store that's running in our cloud, demo cloud. I want to diagnose those. So I can click on here and drill down to the sessions, the user sessions which are having problems. And in this will tell me, okay, these are the different users which are having sessions in my system right now, and they are having some problem. So let me drill down to this specific user. You'll see that this user tried to log in, search, add to cart, and all this different. And then most of the time, this application is slowing down in the application tier. Like here, it says basically the problem. Which tier has how much time it's spent in each of the tier, like redirection or host or network or SSL. So most of the time is spent in the host tier or in the application. So if I want to, for example, see why this login or search is slowing down, I click in there, and that will take you back to the diagnostics for the code level diagnostics for this application. And then help me diagnose this problem. So here, like for example, I found several other traces of the problem at the same time. So I want to click and look at the specific transactions and see where the problem is. So like as I said, basically automatically all these tools diagnose whether what kind of tier it is, like web, business logic, and so it's most of the time is being spent in the web tier. and it kind of provides baseline comparing with like hourly, weekly, daily basis, so you can find out what the problem is. And when this problem happened, the CPU, where did it go? Let me click one more time. Okay, so if you look at here, the CPU was possibly a culprit there. It was taking 76% of the time, and if you want to look at like how this application flew through, so it came from an IE, it went to this Jetty server, and then it makes some request to the Apache Derby database. It has a JMS server based on ActiveMQ, sent some. It made a remote component called via RMI. And if you want to look at the actual application code, you can look at the application code and drill down and find out where the problem is. Like for example, you can look at the SQL statement and all the different thing, whatever you want to do. Like for example, it is trying to delete some. But this is the way you can drill down from an end user point of view to the back end. And these tools are built for the cloud, or if you want to use in an enterprise environment, that works too good and good too. But the primary thing is that these tools are built to diagnose from end user point of view to the back end.
But isn't it true that you are adding a lot of overhead to create this software tool?
Sorry?
I mean, I don't see any value.
Sorry. What?
For you to capture those kind of details.
Mm-hmm.
I mean, I expect to hear when you tell me how you fabricate the test points where you collect the data, how you can account for the deltas in degradation because of your performance tool. I mean, your performance tool is a software tool, right?
Yeah. It's just,
so it comes with a big cost. How much is that cost? I want to know.
Yeah, it depends upon basically what you. So basically, I'm not selling my tool here. So there are several tools. Yeah, there are several tools.
So I'm just trying to question your wisdom.
Yeah.
About building this tool, right?
Yeah.
I mean, anybody can build a tool, but the reason we try to be cautious as an architect in fabricating test points in tools is because they themselves will slow down the system. Yeah, so
that's
sure the access time of those databases, right?
Yeah.
I mean, what's the purpose?
What's the purpose? Yeah. It's help you identify the problem if it is a database SQL statement, for example.
So if the data yourself along the way, what I'm saying is because it is a software diagnostic tool.
Yeah, sorry.
I think he's asking is, can the tool account for its own activity?
Yeah. So these tools, for example, have some kind of, you can say, thermostat. So if you want to set, okay, I do my like for example, if you want this tool should not have more than like say 2 or 3 or 4% of the performance overhead, then they will start basically not collecting a lot of data. So if you see like if there is a lot of problem, let's say there are thousands of requests are slowing down. These tools are built in such a way that they do sampling, so they do not capture all the requests. So if everything is slowing down, if you capture, for example, if only a sample, that is going to help you solve the problem.
So how do you know you are not attributing to the problem? You are not accelerating the system to the point where you self-defeat, right?
Yeah. So what I'm saying is that, for example, there is a self-governor in these tools. Most of the new generation tools have a self-governor. Okay. So if they see, they have basically something called automatic baselining. Okay. And based on that, they decide to collect more or less. So if they see there is a lot of transactions are slowing down. So, and then if let's say you set this sampling frequency as let's say 100%, it is till you have that, it is not going to collect all the data. It's going to throw out all the data because it will see that transaction is already slowing down and most of the transactions are already slow. So it will not capture all the data. It will sample out some of this thing. Yeah. It's basically so it's yeah. So that's what I'm trying to say here. If you have, like, for example, things are slowing down, then all the, like, for example, if all the 1,000, like if you have 1,000 requests per second, okay, if all the 1,000 requests are slowing down, it do not capture all the 1,000 requests. It is going to sample out probably 990 requests out of that, because it will determine, okay, all the requests are slowing down. So if I'm going to collect more data, I'm going to put more load on this applications itself. So I'm going to sample out most of the data. So these tools have been built in such a way that it's not going to put a lot of overhead. And then if you want only 1% of the data to be collected, you can do that too. But it's based on like these tools are built in such a way that they do not put a lot of overhead out of the box.
There's a trade-off, right? So you have to collect enough to be able to diagnose.
Yeah.
But you don't want to introduce too much overhead. Right? So the trade-off is in the art of building such a tool which is really solving the problem, as like to solve a typical problem.
Yeah.
How much is the right amount to collect? Right?
Yeah, so that's what it's like. For example, these tools do not instrument all the classes. If you instrument all the classes, then it's going to slow down. So this new generation of the tools, what they do is they instrument dynamically. So look at, so instead of, like, for example, instrumenting your custom classes, they will instrument only the J2E interfaces. The classes will be basically implemented J2E interfaces. In that way, like, it will be only 1% or 2% of your class, the actual application, which is going to be instrumented. And whenever there is slowdown, they may instrument more or based on whatever the policy you have given. So that's the reason, the way to maintain the overhead on the application.
So, like using JMX, for instance.
Yeah.
We profile the app. How is it different by what you are doing? Are you using more or less the same kind of methodology?
It's kind of the same methodology, but like we have some patented technology how to do is a smart way, so that we do not overload the applications.
Do you use constant threshold values, like parameters? For example, guess that 1,000 classes are examined, it's okay, or like a neural network system or heuristic algorithm?
Yeah, we do basically. So we, with smart way, we kind of filter out most of the classes, like whatever things to instrument. Like, for example, that's what the New Relic, or for example, or AppDynamics, like they do, is that, for example, AppDynamics is monitoring some 1,500 application servers in Netflix in their production environment, and they do not slow down any of this. So the way these tools have been built is that they do not put a lot of overhead. So they have put some self-governor there, but if there is always, you can do overkill your system by changing their out-of-the-box default policies and try to instrument more. So yeah.
Have you considered using deep packet detection on the network? Test the performance of applications rather than having to penetrate the JVM?
We have that technology also. But you do not get to the classes. You do not have the class. You cannot get all the class information by using network sniffing.
But you are talking about end user experience.
The end user's experience product, for example, whatever I have, is completely based on the network sniffing. It doesn't use bytecode instrumentation. So from the
but network sniffing is not intrusive.
Performance.
Yeah.
But if you want to really the code level data, what are the parameters is being sent and everything, then you need to do instrumentation. But if you want, just look at, like, for example, this JSP is spending how much time is spent in network versus, you can get those kind of data by passive trapping.
But those can serve as a hint for you which JVM to hook into the JMX to try to understand the
but then you have to do that again manually. So so you have to determine first and then do manually, and whenever you do that, this could be a one-off problem, or like maybe happening intermittently. How do you do that without doing real bytecode instrumentation?
Right, see, when you sniff the network,
Mm-hmm.
you measure the performance to find the problem,
Mm-hmm.
then you can zoom into one of the nodes inside the cloud to find out what kind of application is running there, slowing down your network. You see that?
Yeah, you can do that from the network perspective. My point is, for example, you can do that from network sniffing, but you want to look at, for example, okay, which this Java class and this was the parameters sent for this Java class. You cannot get those kind of data from network sniffing, and that's what whenever I had this. Yes. Yeah, sure. Yeah, so like for example, there are transaction tracing tools. Like we offer also transaction tracing tools. So I'm not going to sell the product here. So yeah, there are transaction tracing tools that can help you diagnose, for example, okay, with the load balancer, how much time is spent in the load balancer, which load balancer did you use, and then like for example, if you are using Apache or the web server, and you can link that whole transactions where they spend. Even like for example, our tool can help you go up to the mainframe if you are using mainframe or MQ series or CICS. There are tools there. So yeah, so some of the time they do injections. Like for example, either at the some of the products do injection at the operating system level, and some of the true, like for example, do HTTP header level, for example, and then flow through the transactions. For example, our product does HTTP injections and flow through. And then if you are using, for example, JMS in the backend, then it will be a payload, putting a payload in the JMS header. So it's based on whatever it's a combination of technology, what technology you're using. Yeah, so all these tools have their, for example, their own diagnostic server. They have their own database where all this gets aggregated, and that's how they so. Because every transaction will have this unique transaction ID, and then they will stitch all this together. Like which application server is spent, and then like for example, these tools, like they do not like for example, if you do not need an agent in the database to see how much SQL spent, because they do on an exit point. Like for example, whenever the JDBC is being called, look at the exit point and see how much time is spent for the SQL to respond, and based on that, then you can tell, okay, this is the SQL statement that is causing most of the time. But if you want to do further analysis, for example, why this SQL is slow, then you have to use some technology, explain plan for example, that SQL to find out what the problem is. Okay, so summary is the cloud-based applications are more complex, and there are several ways to diagnose, but each and every approach has issues, and you can use traditional tools or log monitoring, but that can consume a lot of time in diagnosing issues, or you can use a end-user based transaction tool to identify the bottlenecks in the application. The end-user piece could be from a passive network capturing perspective, but if you want to visibility into the real application, then that uses some agent-based technology that uses bytecode injection to identify what the problem is. Thank you very much. If you have any questions, then shoot me an email, or I'll make this presentation available in like the content builder, and you can be able to download there. Thank you very much, and have a great time in Java 1.